So, where we last left off on our app, it looked like this. And we were discussing organizing our adherence to the protocols using a nice feature in Swift. And we're going to do that, but before we do, we should make a commit here while we have things working. I'm going to add everything for now. So what we've done so far is we have implemented a table view to display strings representing bird names. Okay. Perfect. Let's also go ahead and rename our branch. Git branch move master main. Wow. All right. So now, as we make changes to our code, if something isn't working, we can always back out to the working state. All right. So we have our UI table view delegate here and our UI table view data source. We spoke in the last video about what each of those things are. Now, the thing about it is that right now we have one class that does the inheriting and the implementing of these two interfaces, and they all live within this same block. Now, that's fine and that'll work, but it does cause some complications for us. So, as we discussed in the last video, UI table view data source contains a lot of methods. UI table view delegate also contains a lot of methods. So, if we happen to try to look up what methods are available to us to implement, this becomes an extremely long list. Moreover, we can't tell from this list necessarily which of them belong to the delegate and which of them belong to the data source. And so we're going to use a trick in Swift to organize that information better. And that trick is a keyword called extension. So now we're going to create an extension for our view controller. And inside of that extension, we are going to keep the code that implements the UI table view data source. Like so. So we'll take UI table view data source away right here. And we'll take the methods from UI table view data source and we'll move them into our extension. Now what an extension will do is it will add this functionality inside of the extension to the class that it is extending. And you can do this with all kinds of objects. We happen to be doing it with our own view controller here, but you can also do it to classes on the iOS API if you would like to. So that'll be frequently used. How would that be used? So there is an enum in Swift referred to as UI color, like that. And you can get different colors from it. You can get blue, black, brown, you can get yellow, you can get red. If you had a custom color that you wanted to implement, you could say extension UI color, and you could define, let's say, branded blue with some kind of a hex value. Now that doesn't happen to be what we're using extension for here, but that's an example of how you would use extension if you were extending an object that's given to you rather than one of our own objects. So extension view controller, UI table view data source. We'll do the same thing for the delegate. Extension. You can also put these in their own files if you would like to, and it's up to you if that's something that you want to do. We'll talk a little bit more about how we decide which logic goes in which files later, but in general, in Swift, each class should have its own file. That makes things easier for other developers to find when they're looking around your app to find what they need. In this case, I'm going to leave the extensions in the same file as the original implementation of the view controller because this implementation is relatively minimal and because all of this functionality pertains to the same class. I would reconsider this decision if this got to be a whole lot of functionality, for example. So we said mark data source before because we know that this mark command creates a heading inside of our file view. We'll also make one for delegate. So inside of our extension that implements the table view delegate, we now have a mark for delegate as well. We don't implement anything yet in the UI table view delegate, but we will. And so it will be helpful to have these two implementations separate because now if I start to complete a method inside of my delegate extension, these methods that you see are methods made available to us by the delegate protocol specifically. Similarly for the data source, if we come in here and we start typing in a method, these signatures are signatures given to us by the data source protocol. So that's our first refactor. Our second refactor will be to rename this view controller. The way that that's done is with right-click, refactor, rename. When I click this, Xcode will do a queued animation. It takes a while in order to rename my class. I want this class to have a name that more accurately represents what I want it to do. So I will call it bird list view controller. And what we'll notice is that in the main.storyboard, this view controller will have its class also changed to bird list view controller. This is something that we want to check because Xcode will usually pick up this rename in the storyboard, but on occasion it won't. And so we want to make sure it's there. Okay, so that's our second refactor. Our third refactor pertains to this force unwrapping up here. We've discussed the reasons that we might force unwrap something a little bit in iOS. When we add this exclamation point to the end of an optional, that means that we are accepting responsibility for ensuring that that variable is never nil when it is accessed. Because if it is, the app is going to crash. Now, in this case, we've accepted responsibility for ensuring that flock is never nil when it's accessed. But in this case, we need to think about what flock is and whether we can really guarantee that it's never going to be nil. Currently, we have set flock manually to a list of values. But suppose this were an application where we were fetching our list from somewhere. Maybe we're getting that list from the internet. Well, suppose we're in an area with poor connectivity and we're not able to complete the list call. At that point, flock might not have anything in it. It might be set to nil. So we have to decide what it is that we want this app to do in the event that a flock is not available. Maybe if our Angry Birds app can't show any birds, we really do want it to just crash. That's an option, and that's what would happen now if this were replaced with some kind of code that could potentially fail. Or maybe we want it to hang forever with a weight spinner. That's something we'll talk about more in the future. One option that is helpful to think about in situations like these is the most graceful way that we could fail and and still provide any additional value to the user that doesn't come from this list itself. And a lot of times, the way that we'll implement that is with something like a sensible default. So, if we have our screen and our flock of birds is not available, what might we want that list to display? Well, maybe in that case, what we want to display is an empty list. If we would like it to display an empty list, then what we can do is we can set a default value on our array of strings to the empty array. Now, when we set this, if for some reason we were unable to complete reassigning flock to something else, then what we would see when we open our app is similar to what we saw when we had not yet assigned the data source and delegate, but the app wouldn't crash. Now, it might not necessarily be the case in the app that you're writing that you would rather show an empty list. Maybe you really would prefer that the app crash, or maybe you would prefer that the app go to some other screen that doesn't display the list instead. In any case, we need to think as we're writing applications about the situations under which our code might fail and what we want the fallback response to be. Sensible defaults are one way that we might handle a fallback from some code failing. So this is one relatively small example of that. Let's run our app one more time to ensure that it still works. Awesome, it does. So let's go ahead and make one more commit here. I'm going to add everything together and then we'll list what we did. Let's say made implementation of list view controller clearer. So what did we do? We renamed the view controller to bird list view controller. We separated protocol implementations into their own extensions and defined an empty list as the default case for our list data. Oh my gosh. All right, there we go. So now we see our two commits. Implemented a table view, and then made implementation of list view controller clearer. Awesome. So we have our commits now, and we're ready to move on to the next part of implementing our list.